It should be live here. Hi, everyone. Oof. They fixed the lighting in here. Yeah. Haze. Not great. And with this desk, I don't have anywhere to stick this big ring light. I can do this. Let me see if I can get this to actually. Slightly better? Slightly better. There we go. Hello, Andrew. So, here's the plan for today. I've got my boxes back. A nice 5090 here. Plan number one, we're going to do a quick couple environment modifications for Kathy Wu's lab. They want contextual RL problems. Basically, they want to like take cart pole, be able to adjust the speed of the cart, the length of the pole, stuff like that. Same thing for breakout. Just going to do this for a couple M's for them. That should be pretty quick. And then we're going to do some more work on the imitation learning algorithm. And I think what I'm going to do with this is I couldn't figure out why breakout was hard. So as a sanity, I'm going to use our standard 3.0 to train a breakout agent. And I'm going to use that as the expert to generate data and see if it trains with IL via that. And then we can kind of work backwards from there, and we can figure out why it is that we can't like bootstrap data from scratch to do the exact same thing. See how much data it takes, we'll see how much training it takes, all that type of stuff. And that should get us into a good spot. We had some pretty promising results yesterday, but they were mixed. We had some really good results and some really like surprisingly bad results. We'll start on this though. Okay, so cart pole doesn't expose any of this crap. Pole mass length, total mass, mass cart, mass pole. And then the magnitude of force. Let me see if I can go find the messages, seeing what specific variables they wanted. And we will implement that for them. We will make sure it trains. Mass of part, mass of pole, length of pole. Okay. They actually gave me a full list. Perfect. So all I have to do we do gravity. Force magnifier. And then update interval. This is good, yeah? A lot of variables, but that's not particularly difficult. And I do like this. M's speed and then continuous. Do mass. All right, what do we think about this? Just do the exact same thing, yeah? And that is all of them. Yeah? Possible context. Want to avoid multi-agent environments. Do breakout as well. Do those two for them right now. They can play with this. And both of these essentially are going to get... These are going to get nuked, right? Astro Jess, hello. Don't want to let you know you're an absolute inspiration and I love efficiency, but can I please ask a super dumb question? Genuinely a sincere one, and I feel like I'm missing something. Absolutely. Kind of the point of this stream. You can ask all sorts of stuff. So all we need to do here is use these instead of the previous one. Threshold. Why do we not just add max steps in as well, right? Guess we'll leave this. Well, we'll do the ones they asked for. PufferLib is optimizing for speed in terms of steps per second. PufferLib is technically we're optimizing for speed in terms of wall clock time to train an agent. That is when we run our hyperparam sweeps and stuff, that is the metric we go for. Which has very high correlation with environment steps per second, of course. And training steps per second. There are some caveats on that, right? Like, if I really wanted to, I can make Puffer hit 20 million steps per second. but it won't train any faster in terms of wall clock, so there's no point. Where's Bet when you need him? He's in the Discord. What, Bet? Yeah, of course Bet's in Discord. Not in the voice or anything, right? Added him in there. Are reward functions for the classic M's like cartpole solve problems, or are they still improving? It kind of depends what you mean. Like, so technically, you could make the reward function like an oracle, right? Like, if you did like a really domain specific engineering, you could make this oracle reward where obviously you'll do better. I don't really look at like, is the reward function a solved problem or not, right? It's more so, can you get it to learn with like a baseline thing that doesn't take a whole bunch of domain specific engineering versus like, how much do you get out of doing more domain specific engineering? I don't look at like a reward function as like a research question so much in and of itself. There are occasionally a couple best practices that come out of stuff, but it's really not the first thing I think about. Like, there's not really a point in improving the reward function of cartpole, right? Like, it's solved in 3 seconds or whatever right now. So, you could say, like, if you improve the reward function and solve it in 2 seconds, that really doesn't let you do anything you couldn't do before, and it doesn't, like, tell you anything new about the algorithms. So the only time in my mind it makes sense to do heavy reward engineering is when you're specifically trying to solve a hard unsolved problem, right? That you independently care about that problem outside of the research value. I commented out the prints too, and also it broke, so yeah, gotta figure that out. Okay, so Bet's gonna come look at this for us. 7 mil rewards per step. What is the post you just made, FBR? Howdy, no rush. When you get a minute, there's a drone PR that's been sitting around for a while. I can just merge it and trust that you haven't broken some stuff, if that is convenient to you. Did I forget to do RK4? And, like, does it still train? I have a whole bunch to merge, it looks like. I also have a bunch of work to do on stuff today. I'll merge yours. Oh yeah, this is the drone RK4. Okay, so I think you PR'd into drone race. I'm gonna have to do some work, I think, to get this into drone swarm, right? If it's... Oh, you did it in drone swarm as well, actually. And this still trains? There was a big one that, like, took me a whole bunch of time, the last one I merged in. That I think was my error, not yours. But okay. I will merge the big PR and just hope that I don't have anything screwy. I'm gonna have to read through drone stuff. Ideally, once you get, like, either you get something on the current drone, or you send me, like, new drone and you can get something on that, I will go spend a bunch of time helping on that side. Like to get drones working. Kind of doing research in the meantime. Thank you though. That, like, having RK4 is really useful because, like, we'll be able to, like, grab this and use it for other stuff as well. Okay, my learning is mostly from Grok. Major bottleneck, like forward passes. Wait, said something like the major bottleneck, like the passes. That doesn't make sense on its own, because when I say millions of steps per second, that is end-to-end training time. Our environments are much faster than millions of steps per second, right? It's millions of steps per second end-to-end training time on one GPU. What did you do here, Bet? Don't ever do that. Okay. That's crazy? Exactly. That's Puffer. I mean, literally, if you just go play around with the library, you'll see, right? Like, on a good GPU, you train breakout in 25 seconds. The task is just solved in 25 seconds. There are other complaints that you can make about the way that we've done certain things, but, like, ultimately they'd have to be pretty petty. It's kind of what you see is what you get. How much time have you spent out helping Yaxian with his super secret? Really not that much. I've had a couple conversations with him. I mean, the thing is, like, we literally have a drone environment to pull from. So if you just hack on that, then, like, the RL side of that is already very good. And then it kind of becomes a hardware project, right? So basically, like, you can look at what we have here as, like, PufferLib just takes one portion of that project that would be otherwise completely unfeasible, and it just, like, makes that side solved. Hang on, did I mess up total mass? Training polytime Turing machine to solve. If that actually works, I will be very impressed. Actually, you should look at Weston. So Weston in the Discord, it's a high school student who made Sudoku, and he says he has it working with Puffer. I'll be very impressed if you get freaking Sudoku to be solved with a Turing machine. That'd be crazy. Got the M to work, that's crazy. Risk of sounding shallow and capitalistic. Create a lot of complex environments in Puffer that have huge commercial upside. It's not shallow and like capitalistic. That's like, yeah, there's business, and we do all the science stuff for free, and we make all these environments for free. But that is what we do on the business side, right? Is like companies pay us to either make them environments or make RL work on their environments or make their environments fast. That is the business model. Because all of our tools are free. We don't charge for those, right? So literally, it's only the things that really wouldn't have any value to general research and science that we monetize. I do that at great personal cost. Like, if this exact same library were closed source, it could very easily sell expensive licensing. So, that's pretty much the only way we monetize. In fact, I can support 2 arrays simultaneously. Huh. That's pretty awesome. I will be very interested to see that, the results of that when I eventually get the Turing machine VR. It'll be a cool thing. I wouldn't have expected that to work, honestly. Probably took a lot of effort to make that work. That works. Good job. Like, fair play to you. I don't really consider it charity so much. I mean, it's advancing science. If you consider all science work charity, then sure. It's just in my mind, it's like my own goal is to advance science and also make money. So, like, it doesn't make any sense for me to go make money and do all the science behind closed doors. And it likewise doesn't make sense for me to, like, just do all science and not make any money. Right? But they have to fit together in a way that's clean, not in a way where you're like, making money at the expense of science or spending all your time doing science at the expense of not actually growing the project ever, and thereby not giving anybody who's involved any sort of financial opportunities out of it. I feel way, way better this week as well, like mentally. I have so much more clarity. I'll tell you what my routine has been yesterday and today. So I get up pretty early. I run a 10K around the dish. It's like a good, a solid hilly course. I come back, I lift some weights, I go walk down, I get myself some breakfast. I go through messages and stuff, and then I just work on this. It's like there's so much freaking noise with everything else. Like, having that mental clarity is so important. Like I now this week I know exactly what to work on. I have like thought through exactly how and like why everything needs to be done. Kind of just in a good spot for all. I honestly don't even think I'm losing any sort of productivity by spending that amount of time doing exercise in the morning. Like, I feel so much better. And don't waste time working on dumb stuff. The result. Why did it just add that crap? Welcome, Kinvert. I see you have a whole bunch of PRs. I will get to them. I'm going through my laundry list of things to do. Working on some of it anyways. About this new sparse learning. Oh, the imitation thing. Um, I will be working on that soon, later today, as soon as I finish this. Uh, I'm adding a couple changes to Puffer for Kathy Wu's group. Oh, imitation learning? Yes, that is what it is called. It's not. You're not gonna find good literature though, because the thing I'm doing is weird. The heck? Oh, watch your branch. The thing is, I'm doing imitation learning, but there's no expert data. Does that make sense? I'm using imitation learning algorithms with data that is not derived from experts. There's some details for how that works. Let me go message them. Okay. Wait, what is FBR linking me? Huh. Sam and I have been messing around with using inverse RL with no expert and got some results. Inverse RL with no expert. Why would you do inverse RL? Like learning the reward function, right? Like you have the reward function, don't you? I would think that you have the reward function. Why does Breakout have high perf pong on it? Sparse to dense. Okay, interesting. Well, if you guys want to do research side stuff on Puffer, like, there's definitely room for that as well. Though I would suggest the initial contract stuff will be likely to come from Drone. Um, research side, I'm trying to think how the heck that makes any sense. You're trying to label the data. I'd have to see the details of that. That's kind of wonky. The imitation with no expert makes more sense to me because you can just do like a best of N type thing. Or like a top K. So there's actually something to bootstrap. I don't know what you're bootstrapping in the inverse RL setting. Work with some tricks. Well, if you have cool stuff there, you know the research like agenda here in Puffer, right? Like we try stuff on everything, and if you have convincing results, that would be the type of thing that could make a major Puffer release, yeah? See what variables they gave me. Speed, no gravity. Is it possible for an RL newbie like me to add any value anyway in a short time horizon? I mean, this is how most of the people here got started, right? I've literally made I've made a guide that is, I guarantee you, the quickest way possible to get into reinforcement learning. Not trivial. If you have, it depends on your programming and math background, mostly programming background, for how long it will take you. I have two guides, right? I've got my advice for programming in ML. I've got my opinionated guide, really ultra opinionated guide to reinforcement learning. If you read this and actually follow this and know what is going on here, you will be a very capable contributor to RL. It's just a matter of how difficult it is for you to do so, whether you have the time to do it. Weird. We're gonna have to go through this in a little bit more detail, I think. What's hard coded? Let's turn with DQN style things. No, like vanilla DQN is a useless algorithm. It doesn't do anything. So there are off-policy methods, which are like DQN with a whole boatload of like things bolted onto it that seem to work pretty well, but like the evidence is very mixed and a lot of the research is not super high quality. And I just spent a week talking to a bunch of DeepMind researchers who worked on these papers, and I got like I got some good information on promising directions there, and that is the thing that I'm going to be working on later today after this. It's not quite the same flavor of thing, but it's like a similar motivation. I will say it's definitely there is not clear evidence that like, oh yeah, off policy is just better or anything like that. In fact, most of it's kind of the opposite. And like off policy has a lot of problems with it. I really should go through a lot of these like environments we use a lot and just clean up code. It's kind of embarrassing to have some of these be such a mess. Just clean like pure refactor, clean up that. I mean, it kind of is what it is, right? Like DMs are written by contributors of very different skill levels. And like the M's are independently useful in research anyways, but the ones we use a lot, I'd like the code to be just very clean. I honestly think being a good programmer, like a very good programmer, is harder than being a very good AI researcher. I don't know why you would have used Breakout as the template when I have like I've linked you other environments that are cleaner, right? This is why I made the template environment and like Target and like I made all the other ones like plus even Snake is decently clean. I have all these other environments there so that you can see what like a clean environment would look like. My first day, man, that's all right. But that is how you eventually get better, right? Like if you go look at I think Spencer's first environment was Triple Triad. If you go look at the the horrendous code that is versus the awesome stuff he's building now, it's like night and day. What the hell even is this, right? Like Like, literally, what am I looking at with this? And it's like, oh, it's just formatting code. No, it's important. Like, don't make your stuff a freaking mess. Like, I don't even need to be following a style guide to, like see that obviously this is better than whatever was there before. Heck, you can even do this. It's a little long, but it's fine. Hello, Dinesh. Welcome. Oh, we already have ball width. Watching this mostly in the background. At all. Yeah, no worries. You're not required to literally spend all day watching me work. Yes, all Puffer contributors must be glued to all streams. All, like, 40 hours a week of them, or however many I do. It'll probably end up being about 40 a week. The next block is likely to be, focused but not crazy long hours, if that makes sense, because it's mostly algorithm. Miss sending you a message? Oh. Oh. Like, what? I am sorry I can't watch you all day. You'd be surprised the number of people that, like, said that they knew me from the stream at the conference. I met Kovacs. I've seen in here a few times. Link in Discord for breakout, and I can apply. Relevant change tracer. Oh, this I'm not really. So what I'm doing here, this is like exposing variables because Kathy Wu's group wants to use this as like a contextual RL problem. A full refactor of this would take me a lot more time. Like that could be a full day, like an all-day project, frankly. I'm not doing a full refactor now. I'm just exposing a bunch of variables and making sure I don't break anything. And then we're gonna do imitation learning today. Yeah, that's the idea. Such a freaking mess, you know? Did I do this? I don't think I would have. Maybe I was on like some jank editor. Better, at least. What did I do here? Expected. Oh. I don't know why it does this, but my editor, it likes to add a G character to the start of files for some reason. And like it replaces weird. Off policy could help getting good initialization. You'll actually like what it is that we're gonna do after this then, because I think I have just a better form of that. I think I have just a better form of that. So the problem is, as far as I'm aware, and as far as the people I've talked to have been concerned, it seems, is like off policy is kind of a lie. Like the idea behind off policy is you can just infinitely reuse your data, and it doesn't seem like that actually works. Okay, so this runs exactly the same as before. Done, that trains. Perfect. Super fast, still 25 seconds. In today's stream, yes. It will be right after this. I'm committing this. I'm gonna use the restroom, and then we're gonna start on the imitation stuff. And it's like a better... It's a weird form of imitation learning that's kind of a substitute for off policy. You'll see. And it doesn't use expert data, though we are going to get some expert data as a baseline, but it doesn't need expert data. Throwing my poorly constructed thoughts in here from light controls. What? The message might have eaten something there, and it doesn't make sense. Light control certification back is where Oh, okay, I see. You can't. Like, yeah, you just can't. Like, deep learning as a whole is not interpretable at all. It's like asking how can we get the, like, it's not the same, and it's a really dumb analog to say this, but it's the best one we have. It's kind of like asking to make a person fully interpretable, which it's just not. Like, that's just not a thing. No. Okay, so this is the imitation thing that I have. All right, let me show this off, and then I'm going to take 2 minutes, and then we'll work on it. But we'll kind of show you guys the initial thing first. So, here's the train function. You can see that all of the logic here, it's like the normal RL is commented out, okay? And then you have this super short imitation learning loop. Okay, not that short, but it's literally just imitation loss with, like, entropy coefficient, okay? So there's not actually any RL happening in here. Hang on. Gotta rebuild the ends, and then we'll show you. There you go. So, solves cart pull just like before, right? Start solving Pong. If we train that for like an additional second or two, that would full solve Pong. Alright? If we train Breakout, it doesn't. It doesn't remotely solve it. But it does substantially better than Random. And also, the thing that's kind of crazy about this is that it actually does really, really well at the first part of Neural MMO3, like way better than RL does. We're talking about hard initial early exploration. The question here is like, why does it work on some problems, even some of which are pretty hard, and not on others? So what we're going to do is we're going to train a breakout agent with like Puffer 3.0 RL, and we're going to see how much data you need from an expert to IL, and we're going to use this to assess what's going wrong with this. Sent pull request. I will look at that. I want to do imitation learning stuff right now while I'm in the mindset for it, but I am very excited to see how big is this. I will look at how big this is. Okay, that's about what you'd expect. It's kind of going to be chunky, right? Oh, geez. Why did you have to do all this PyObject crap? Wait, we literally have a binding thing so that you don't have to mess with this, don't we? Holy. Alright. And then 1,000-ish lines. Wait, why is it all in the .c? Wait, how is this all in the .c, man? Because the .c doesn't get imported, right? It's for testing, okay. You were training it, though, so somehow you were training it. Wouldn't it have to be in the .h for that? Because the .h is what gets included by Puffer. How much of this is GPT? I get suspicious when I see that number of comments. %, Claude. Okay. That is an acceptable percentage. I have to ask because when I get mad when people ask me to like review things that are like 80% just AI generated, right? Funny. I never trust these models to touch my code. They just cause so many problems. I mean, this is about what I would expect, though. This is like just straight up, yeah, you implement the single purpose physics in about the amount of code that I expected it would be. If you take the comments out, actually, it's probably like the 1,000 lines is what I said. It would be about 1,000 lines. Okay, so get this thing. I don't understand how that this is even training if all the code's in the .c. Because you did send me training demos. Like, get whatever the final cleaned up version is. Get some cool experiments in. Comment on the PR. Like, comment a link to either Wannabe or Neptune or one of those, so I can review some of the train curves and like add a couple images or a couple GIFs or videos or whatever. And then we will set up a time this week, and I will give you a full review of this. because, well, you can decide when, basically. You can decide how much more time you want to spend on getting better results or whatnot first, because this is the type of thing where, like, if you can actually get a 6 degree of freedom arm to work really well in a way that is very robust, this is like direct link into contracts with us. But it depends fully on how good the actual implementation is and on follow-up stuff. References for the math as well. Well, where did you get the math from if you don't have references? Like, where did you get the math? Oh, I'm sorry. That was... I read those as the same name. I just looked over. Okay, that's Finn asking. Short name that starts with F. All right, cool. Well, you know what? Then you know the basics. I mean, you know the procedure at this point. I'm gonna use the restroom pretty quick, and then I'll be back in a couple minutes. Grab myself a drink, and we will start on the imitation learning segment for the day. Be right back. All right. First things first here. We gotta train ourselves a baseline. Might just have to play with the Manny scale, Paul. You can ask me stuff if you need, because, like, there was a line that you have to modify. I can probably help you find it. Okay, so this is fine, and now what we do is... Neptune not got my token on here. Guy token. If I can't figure it out, I probably won't be. Yeah, the thing that's difficult with Manny skill, so I played with it for a couple days, and I still want to do stuff because Stone's awesome, but, like, I couldn't find decent settings to run it fast enough to make it, like, to really be able to do much, right? When you're training 50k steps per second, it's just not a good spot to be in with RL. Which is why, like, doing our own arm or something like that would probably be, as hard as that is, probably more reasonable, just because you need to be able to train at a decent speed to do anything in space. Like, tens and tens of thousands of lines of code across, like, several different frameworks to make anything worthwhile. Okay, good. Yes. Now, how are we gonna use the expert? Because, like, we need to still know how well... We need to still know how well, our agent doing. Congrats on RLC. Hey, Akars, thank you. We're doing all sorts of crazy stuff on Algo side now. Yeah, I put the talk up on X and YouTube, and I've got to archive the paper, but I'll have the paper on archive soon. Working on experimental research for potentially Puffer 4 at the moment. Why weren't you at RLC, man? It's like the RL conference. You off doing A-Life stuff now? I think if I just totally hack the I just totally hack. You'd have to literally have a second set of environments, though, no? Not really mainstream RL. Now, if you consider like the mainstream thing done 10,000x faster at times, 1000x at others, suppose this is mainstream. Not really at all, though. What would I do with this? Want to hack this to have second set of environments. Is there nothing easier I can do? Really, right? Oh, the wrong branch. There. Good thing I caught that before I messed it up too much. Okay, so we just take all this data, right? Yes. A contract with you guys if you do that about. So the way that Puffer works, right, is everything on the business side is contract based. So it is, can you get companies interested in working with us based off of simulations that you've built or like other domain experience that you have in addition to the RL stuff with Puffer. So the reason that 6 Degree of Freedom Arms is likely to be contract worthy is that there are a ton of robotics companies, and all of the current sims for 6 Degree of Freedom Arms are really slow because it's the same sim as is used for higher fidelity robotics like humanoid hands, full humanoids, things like that. So having a good and very fast sim doing impressive tasks and then also doing some work on like talking to robotics companies, right? And like getting them interested in doing stuff with Puffer. If you're able to do that and we're able to swing a contract off of it, you will be on the contract. That is essentially how you get into business side stuff of Puffer. It is by being good enough to build out applications in specific domains around Puffer, and then using your work plus the general recognition of Puffer in order for us to partner on a contract for a company. How that works. It has to be good though. Like it can't be the type of thing where you kind of build a sim and we have to go get a contract and you're not going to be capable of working on it, right? Like it's really much more independently driven. Occasionally I do go to people who I know are good in specific areas for contracts that I have found. But the way more consistent way of being able to do this is to be able to actually go build a thing, find a company that's interested, getting them talking to us. That's the easiest way to do it. Okay. That's something. What should this be doing now? Expert vecend receive. This should be populating buffers with expert data. And we should be getting stats. Yeah, we should be getting stats from something totally different. Sense, right? Instead, we have KL blowing up. Nanning out instant. Cool. Very cool. Okay. Let's just move this here to here. Okay, so this is the expert data. See, it actually does get the score it's supposed to be getting. The heck? What? Why are we on 3.0 branch? I literally checked this so that it would be on the correct... Damn it. Let's see if this is close enough that it's actually done something for us. This, we got this. Rebuild this, and now we're going to try to train this again. Should be imitation. Dramatically different, right? If we're doing this correctly. Yes, this is being done correctly. Because what we're logging here is this never going to eval? Why is this not going to eval? Good eval, no? Yeah, why is this not, evaluate? Again, this bot. Weird. Using to do the final evaluation. See why this is not evaling. We need this to eval so we can actually get final data. It's crazy, by the way, just how stupid easy this is. Like, oh, we can just do imitation learning if we just have data. Yeah, if you actually have data. Not even a problem to solve. It's just oh, I know what it is. But it is fine. It's just that I forgetting to close the end. 96. Closes. Perfect. Okay. Be happy with that. Except, why is this like? Now it's just training on all the data. And this does a little better. Interestingly, does not solve the task. Not solve the task. Oh, wait. Hang on. Is this... Might be being... Okay, that actually makes a difference. Increase the update epochs. Yeah, like, increasing update epoch seems to actually make a big difference here, right? Lo and behold, supervised learning scales. This little dip here, is it getting over the first screen of bricks? That's an expected dip. I think only 500 more epochs. Bit. Fuck. Fast. About the same. Better with 2. Is that just noise? It is magically better with 2. It's interesting, though. It doesn't just... If it does not learn from this as well as from the RL, kind of odd, isn't it? Yeah, 2 update epochs is better. We get 600 score. And now I know it would solve it if we just kept going, right? Let's ignore that. It should be able to learn from 6 4-length segments, right? Isn't that kind of crazy? RL being more efficient than mutation? Be the other way around, no? Absolutely should be. Maybe there's just some jank. That these make very slight differences at most. I do somewhat worry. The thing is, the episode lengths are super long in Breakout, right? I do somewhat worry about that it's just that. Yeah, there we go. So it's just that the number of environments is super large. Um, you're not even really seeing data from the whole game, I don't think. We'll do the back of the envelope math in a second. As soon as we know it actually solves. It does actually appear to be a little stuck, doesn't it? Okay, 725. So a good score, but not actually solved. 14. This is, yeah, there you go. So pretty much, if you start just like running a ideal policy with this many environments, it won't even finish a full game by this number of steps. That's the main problem. Kind of fun happens, no? I just like 725. Let me just make sure. Not like super sensitive. And then after this, I'm trying to think what this tells us. I mean, this does tell us, right? Like, and let's like ignore a second the fact that we're kind of doing this in a way that's a little janky. If you have, oh, that just nans out. That's funny. Okay. So if you have a good IL, and let's actually just do one other thing. Make sure that this is actually going to solve grams. If you actually have like a good policy, can pretty easily IL another one based on it, right? Purely just by matching actions over segments. I mean, this is kind of obvious, right? But now the question is, what's so special about the RL, right? Like, why can't we just IL a policy from scratch? Just by like keeping around the best data, the best trajectory segments. Okay, interesting. So, this actually doesn't fully solve it. Likewise, we get like this high-ish score, not fully solved. That's a little odd. But it does do way, way better than our IL from scratch, obviously. So what is the difference here, right? Well, hang on. We have a few things, don't we? So if I just take our gold samples, if we do it like this, how well does this do? Okay, so even this does pretty decently. So what this is doing here is just keeping the best data from, it's keeping, like, the best batch of data, basically. Just, like, grabbing all the best segments based on reward. Now we know that this approach also can do decently well. So then what is it that is preventing us from doing this without the expert policy? Because if we don't make any change to this, if we make no change to this except swapping out expert for the policy, now it has to generate its own data to learn on. Not like it doesn't learn anything, right? It learns something. Very inefficient. Very inefficient. Let's go mess around with the original formulation a bit. I think that this buffer, we're gonna make this buffer way bigger. Buffer, like, way bigger. We have a big buffer. Way harder to overfit now, right? Select good transitions. Taps out, though. Starts getting worse. Actually starts getting worse. Huh. it makes sense for me to try to get like a batch IL thing going. Not like showing strong dependence on. We would think that it would be more sample efficient, even in like, it would be better by all metrics, even in the easiest or like the simplest case. Like IL should just be easier than RL. We have basically a perfect data generator. Like so disconcerting to me in some sense. Back to a few different. Let's add in this way. Exact opposite. Wait, I can't follow along perfectly due to my limited understanding. But does off policy method have to do having more data efficiency, computation efficiency? Exact opposite of on policy have anything to do with this? Aren't going through. Yeah, YouTube sometimes will filter things if it thinks you're sending links, whatever. It's kind of weird. The thing is, I don't actually know if off-policy methods are substantially more sample efficient. Like, based on some recent stuff I've seen. And this is not either. This is imitation learning. This should definitely do something. And, like, it's working, but it's actually... It's funny it's not closing out the environment. Not learning the final bit that it needs. Here if I can just do... be able to distill it either way. So odd. Just do one thing that's like super basic. Yeah. Kind of tricky. Okay, what if we do... This is a bust. Need a restroom real quick. PufferLib add rendering to WandB. So technically, yes, Kevin. It's just the massive amount of data that you end up accumulating as soon as you start doing that by default. But I'd probably want to do it as like an off by default thing. And the other annoying thing is like we actually have to figure out how to do that with like you need headless rendering for ocean ends to do that, which is doable. I think a couple people have gotten it to work, but I haven't integrated it yet. I'll be right back once. What the heck happened to episode return? It nanned out. All right, maybe this is just like weird hypers being weird, you know? Maybe this is just weird hypers. It should not be nanning out. Yeah, just hovers around these 700s. Oh, there's some 800s in there. Actually closer. Then it nans out. Okay, it nans out at the end. PPO always better than SAC when data efficiency isn't an issue. Yeah, I don't know. And nobody does comparisons correctly on these things. And I don't even know if SAC is better when data efficiency is an issue. Because I talked to a bunch of DeepMind people about like all the off policy stuff that they do and such, and it's actually become kind of unclear to me. Like off policy RL in general is kind of a mess. Right? Why the heck does this not just solve? Right? This is basic ass imitation learning with an expert. Like, why is this being so weird? Okay, it's pretty close to just solving, right? Off policy. Um, because like nobody's ever really done controlled experiments at all, Kevin. Like it's everybody's kind of been pushing sample efficiency on these off-pol methods, and like they have crazy settings for these things. Like the sheer amount of compute you're using with these methods, like nobody does this with PPO, right? They've gotten themselves in this like insane data regime where like they're spending a huge amount of compute on tiny models with tiny amounts of data, and like nobody's ever really tried that in the on-pol settings. It's basically just two diverging branches of research where like nobody's ever bothered to compare correctly, and like the data hygiene practices in both settings are awful. This is like closer though, at least like 800 almost. Like fairly confident we could make something, right? I mean, regardless though, just like at least does something. And Astro, I shouldn't need a bigger model because the expert is not a bigger model. I should not have to distill into a bigger model. If anything, I should be able to distill into a smaller model. I'm trying to think how to interpret this. If it's just a screwy reward sparsity, you know? There's no value function. It's a very sparse reward, right? P over sac is like the most basic thing. Pair. To decide if you value based. You typically don't. You typically just use your favorite. Like none of the basic stuff in RL has actually been done correctly, Kevin. Like at all. Okay, what did I break? Because now it's like way worse than... Oh, now because I don't have the gold buff. Which it works this way as well. Look, the simple proof of this, right? Okay, I'm able to train at millions of steps per second, right? So that means if I want to run a 100 million step experiment, it's done in under a minute, well under a minute, right? All right, so if I have a 1,000 step per second RL library, and a lot of them are even slower than that, okay, and I want to do 100 million steps, okay, and then let's do in hours. That's 27 hours. So it takes longer than a day to run a single experiment on a GPU for like a super basic environment. Your dev loop sucks. You're not going to get anything done. You're not running enough experiments, and you're not doing basic hygiene like running many seeds and hyperparameter sweeps, except maybe like a few seeds for the final experiments. All right, and then they actually with Ataru, then they run all 57 of them, so they're not doing any of that stuff. So like, it's literally just impossible on the speeds and on the academic budgets that people have access to for the science to be any good. That's it. Yeah, so we could Astro if I were to do high perf SAC, but like that's not a trivial thing to do. Like it would take me a while to do that. Not like I don't think that there's any data I've seen that's like so massively in favor of SAC that I expect it to do anything for us. Okay, so this is the. Hey, break it again. Oh yeah, hang on. Oh, we want to. Let's let it actually run like this. Um, then we'll go back to the number of M's that make sense. We should try this on some more environments. See if we can like predict what this is going to be good on. Just sparsity. It up. Okay. What M's do I have in Ocean I could use? Triple Triad didn't work, right? How does this get 0 rewards? Doesn't make any sense, does it? It's all negative, is that the case? Negative reward. Do anything? Think this changes in here. Change anything here? Chris. Power. Huh. Maybe there is just something weird with like the reward sparsity going on, right? This should be an environment that's like not a super easy environment. Doing definitely non-trivially well. We still get the same effect where like on the harder ends it fails to close out. Like it gets stuck. Need a bigger data buffer maybe? I think it's just that, right? It's not just like, oh, give it a bigger data buffer. The fact that like so quickly. Oh, that is a little better. Huh. Maybe this is the env to use for testing. It has like very short episodes and a very well defined score. Then it gets stuck. 5. which is very close to what we have in the buffer. I believe it's just a +1. Hmm. Okay. If I do this, mentioned at the beginning, DroneEnv basically solves it from an RL side and it becomes a hardware problem. What does RL accomplish and what is there to do afterward in terms of hardware? Well, I mean, you can fly the drones around in simulation. You can randomize them in simulation. Uh, the actual learned control works very well. Obviously, you then have to actually put it on a drone. And if it's a custom drone, then you have to build said custom drone and have the sensors be sane and make sure that whatever the heck that drone is at least somewhat matched by something in the randomized training scenario. Without PufferLib, you have to both do that and figure out how, like, the crazy cursed RL that doesn't make sense can be made to work. It is interesting to me. The gold reward is getting higher the bigger I make this buffer. Now, it could just be that this is getting filled up with easy levels, right? That would be a problem with doing it this way. Filling up with easy levels. Yeah. Because now, unlike before, right, we have a pretty solid buffer. The perf is maybe a little higher than before, but not really. I wouldn't be surprised in some way that it's something about the way I'm doing this. Why are there some shillers of Isaac and on Twitter? Well, the thing is, like, if you're doing humanoids, for instance, you're not going to go write your own humanoid sim. The problem is those packages are these really big, bulky physics sims that are super slow when you have, like, relatively simple form factors. Um, but, like, the vast majority of roboticists are not simulation engineers. Like, they're not going to go spend their time working on how can I make a better sim, right? They spend their time, like, fiddling with control algorithms and training and setups and stuff like that. Do you see Puffer training robotics over the next few years? Well, I mean, robotics is really just one application area for us, right? And it's not even necessarily the biggest one. We're gonna have our drone project. I think that we should be able to get something pretty cool out of that. So you see, like, yeah, you can do this stuff. You can do it in fast simulation. You can do it very well. Probably gonna have, and we've already had one person working on, like, a 6 degree of arm sim. See if we can get that to work and throw that on real hardware. And depending on how those go, then we'll see what else we do in robotics, right? Like, one of many problems that we can solve, though. Something weird happened here, because board in the buffer kept going up. The performance did not. Performance stalled. I guess this is the main difficulty is how do we actually make sure we're getting good data in this buffer that's like diverse and interesting. Yeah, that's the key problem here. Because, like, we know that we can learn. I mean, initially, what happens if I just... What happens if I just do... Say we kick out 64 samples per tick. That do for us? We'll see how this compares. If there's a substantial difference, then we'll know it's the bias in the data. If not, then we'll have to think about this more. It's so weird to me how this will get you like a relatively decent policy so quickly. Not even using any RL. It's tough because this feels like incredibly powerful, but it has weak spots. And they're different weak spots from what I'm used to with PPO and such. Very different weak spots. This appears to be doing like substantially worse than before. We'll see by the end of training. The fact that this does something on our hard M's though is crazy. Not a super env here at all. If this has to be full episode. It still wouldn't work though because you could still save like the easiest levels, for instance. So actually prioritizing your data just off of reward, pretty tough. I mean, there's a massively less sample efficient thing we can do. Kind of defeats the point, but is a good experiment to run. Going through CS231N lectures and problem sets as suggested. Thoughts on what Justin is building? I meant to go visit because I just heard that he's actually in SF. Um, so I meant to go visit because I haven't talked to him in years. I interned with him as a high school student, actually. It was like the first bit of research that I did, but I haven't talked with him in a long time. So if this fails completely, this will be interesting. I expect this to basically just save the easy levels. So basically give itself a very bad curriculum. Like if you study for a math test by only solving the first few problems in the section. That would be consistent with a lower score. Like a lower but still reasonable score. Well, there's one thing that we can definitely try. That we would expect to be like substantially less sample efficient, which again kind of defeats the point. Well, it still won't sense, and might not be want to use for testing with this. This is lower. Get something that's like more monolithic, I guess. No, I'm surprised that triple triad doesn't work. I'm really kind of surprised with that. Like, why shouldn't triple triad work, right? If you looked at what building at World Labs, I have no idea what they're doing. I really have no idea what they're doing. Something like this failing is weird. Something like this failing at least is positive score. Very poor. Very, very poor. Negative 0 point. Really? try this, but I doubt this makes a difference. It's kind of weird how I can't really predict what ends this does stuff on versus. Can I not do connect 4? Try connect 4. Oh, right, because it's kind of slow with the opponent. I don't want to just fiddle with this forever. I'm trying to think how I can leverage this. Getting a value function. RL giving you a value function is so powerful because you get like reasonable estimates of segments even when there's not reward there. Like you get state estimation out of it. The tough thing. So this does not have any state estimation basically. But then the problem is when you have a value function, like that gets stale. And also if it has errors in it, tough to build a data set out of. Now I am kind of confused why. Why does this not work? I tried this. Other way around. Maybe this does work and is just very data inefficient here. I do this. This is like a straight up best of N, right? Get stuck already at 18. Guess there's just super little variance in the data then at that, huh? Entropy is super low. Oh no. Problem is this is now completely off of the original objective of the sample efficiency. Not even faster wall clock, even though it trains super. Even though like it's high SPS. That is in some sense a very easily scalable method. Best of n. What if we try to do like something offline? Problems when you go to offline, you end up with the same bloody problems off policy has, don't you? Yeah, because then you end up with like, yeah, literally all the same problems. What are the issues with off policy? Well, it's the methods get very complicated very quickly because so the base algorithm in on policy of policy gradients, you don't need to bolt that much stuff onto it before you have a soda algorithm, essentially. Like if you just take on like just policy gradients, you bolt on advantage estimation and clipping, you already have PPO pretty much. Whereas if you take DQN, it just fails horribly at everything, and you have to bolt on like 6 or 7 different tricks to even get it to be comparable to PPO. I'm also trying to figure out how's a Q function even for you from there? That function. Behavioral cloning. What problem do you have? Big enough data set, you don't have any problems, right? Of course, I tried to do it piecemeal, so I hit problems. Big enough data set, have any problems with cloning. But with sparsity problems with online RL, major sparsity. Of course, you can't reuse data. It ends up being expert quality data. Is there any other way we can go about this? I don't want to type this shit big rock. I'm trying to think what else I can come up with that'll like give me a good answer. Who I spoke with at NeurIPS. Is this the on? Is this off policy? Oh, okay. So this is off policy. The VMPO separate. Okay, so this is the on policy. I didn't realize this. There are two versions. There's an off policy version and there's an on policy. So this is probably what I was directed to. Super math heavy paper. Very, very different out potentially here. Do they have a pseudocode block? MPO cheat. I can understand this at least a little bit. PM. Okay, this is an EM application. Liked more experiments. What would you say would you say scalability is one of the drawbacks of off-policy? No, it's just look, basically the only actually good off-policy research, it's like a small handful of DeepMind papers behind closed doors that don't have a ton of context. Like all the random robotics papers using SAC for 1,000,000 steps on the same 3 tasks. Like you can basically just ignore that. It does bother me here that they only do control tasks. Why did they do this? Okay, actually this will be a better look at. Would run from full state. There's this. I think they don't have comparisons to itself, but I think we can together. Task name equals run domain. That 7. Wait, what? Same problem. Any luck on material science? I've talked to a couple people. I need to go back to doing it. I'm doing core research at the moment, though. I'm taking a break from doing, like, building more applications to do a little bit of research. Sorry to run from more experiments in here, or this is what I have to work. Wait, what? SAC and PPO are on top of each other here, right? MPO's up here, 25 mil, different number of steps. What the heck is this? Scaled with different architecture and well. Oh, we do have MPO on here. They have MPO as the best baseline for this stuff. I probably do have to actually understand this thing. Weird though. I think is there anything I can take from segment though? At the very least, can say for certain that we're nowhere near optimal with our current algorithm. The fact. Can say that for certain tasks, in a very simple like data collection strategy with imitation learning, works very well. Also a fact. Also say it does shockingly well on some hard problems, including at least better initially than our best online RL method. Also a fact. They ever in they wrote this follow-up. Why would they write this follow-up? They tell us? It's interesting that they wrote this paper. They just want to adapt this original to high data regime. Is that the idea? Top K advantages. Yes, so this is actually, this is in ours as well. Okay. The fact that they wrote the original off policy paper and they wrote a follow up on policy is kind of telling in some sense, isn't it? Like, why would they do that? Fast Mark LM. Why didn't they? Is it slow? Like, why? They didn't even give themselves reasonable MPO baselines, right? Like, look, they just treat. Where is it? Okay, look how crazy this is, right? This is what I say about science in this space just being weird. Why wouldn't you just run MPO? Like, why wouldn't you do a learning curve for MPO? It's literally your algorithm. These are both DeepMind's similar, like, shared authorship. So they just have this line at 40 million steps. What they say here, right, is that MPO is better than SVG, better than, where is it? PO. They say this is better. But they don't actually do a comparison curve. And this thing is a tiny number of samples, 40 million. And then here, they do better than MPO once they have 2 billion environment steps. So according to their own experiments, and here's like 600 million. According to their own experiments, this thing is like massively more sample efficient, at least up to this level of perf. But they still wrote this algorithm and have this paper. So presumably, like, there's got to be a big difference in computation applied somehow. I have to understand the algorithms more for that. So definitely going to look at these two. The other thing that I think is interesting, right? This is as far as I am aware. This is like the last core algorithm paper. MPO and VMPO. This thing also include algorithm changes? I mean, network changes? Did they use a transform? Board network. I think I trust this way more. The other one. It's already a senior on this. But when you go to this paper here, right? It's only, was this 2 years later? This is just a ResNet. They didn't keep the architecture for this. Actually, do we have curves? Wait, this makes no bloody sense, right? Yeah. This thing makes no sense at all. Look at this. They're doing billions of steps to solve breakout. Yeah, I don't trust this as far as I can throw it. Multitask stuff is interesting. But then that's not a heavily contested benchmark. Basically just keep mine doing that. Okay, so they did adapt this thing. Probably some high throughput thing as well. But like the results kind of suck. Unless I'm missing something here, right? But don't these results just kind of suck? Like fancy architecture, billions of frames, or freaking Atari, like Breakout, 5 billion frames. Yeah, and then they're baselining versus like PPO at 3 million steps. Like, oh, it's down here, it's 3 million steps. Honestly, the interesting one is the MPO being higher in sample F on this. Also versus SAC being very close to PPO on some of these. I think what we take from I think we have to start looking at the details of this paper. Wrote this. I suck. Some random. Dude, what are you doing? Absolutely deranged programmer. Very complicated paper. This all of it? Yeah, this is just a network. Just a network buffer. Okay, so at least this is the entire implementation. Entire implement. There's also this update critic T. Let me see if I can understand at least a little bit of this. Policy evaluation. Update critic T. Loss. This is down here. The forward pass. Get categoricals. Take log prob export that. Expected view. Discounting. So this is the one step wrap. Loss and give it Y. Stated. This is fine. This is fine. This is mini batch, right? Compute this loss. Critics. Then you get dual function. Just compute. Do multiple iterations on this. There's the word pass. A totally crazy algorithm. Obviously, there are a ton of details to this. I'm gonna have to write Martin an email, I think, before I go too crazy into this. I'm trying to think what's the most productive way for me to go about things right now. I have some initial results. They're not good enough to turn into a new algorithm just off the bat. They are enough to convince me, though, that there are substantial holes in the current algorithm, like qualitative holes in the current algorithm. Neural MMO experiment probably being the most convincing of that. Mostly around reward sparsity, I think. Sample reuse sparsity. I'm gonna have to email Martin on this. And I'm gonna have to do some thinking as to like, do I want to invest in doing a full MPO implementation? I think there are more things I don't understand. The other thing I really don't understand. Here's the question to people, actually. Here's the question for the audience, if anybody has any idea. Off policy is supposed to be able to is supposed to enable sample reuse, right? Because you're no longer the problem in on policy, right? Is you're getting data from your policy, but then you're actually evaluating your data with a value function, and when the data is old, the value function is stale. You're not actually going to be able to, like, data that came from a previous policy is not going to have a good value estimate, and you're not going to be able to compute advantages, and the whole thing falls apart. The thing I don't understand is how does off policy fix this if when you have a Q function, right? Like, okay, Q function gives you the value for each action you could take, right? So for that one step, that makes sense. But the problem is you're still training it against this discounted return of what happens if I take this action and then follow my own policy or whatever. And if I follow my own policy from there, then, like, you're still going to get off policy, aren't you? I'm probably not phrasing that great, but that's the thing I don't understand. Like, does this even fully make sense? Because I talked to Pablo at RLC. He said, like, yeah, we can't even really do more than 8 update epochs on our data with off policy. So that seems really weird to me. 3 o'clock, 3:12. I have a separate project that I could work on now if we're stuck on this, unless anybody has any ideas there. I have a separate thing that I can work on. I'm gonna go. I'll be right back and I'll think about this for a minute, and then we'll see. Let me get another. No, I'm still good here. Okay. So let me think a little bit more about this problem before I just move to something else, because I'm kind of in the right mind space for this at the moment. You're going to collect policy pi state. This gives you action. And B Q kind of value as well, right? It gives you a value. I'm going to collect a bunch of data. And I also have the actions. Words. Okay, so we have some segment here. What I'm just doing now is I'm saying this segment is good if we have it just has high summed rewards. Alright, so this is what we have now. This is one thing. We could do should we just add the value? Could add the value of the final state to this. Not easily though, right? Because we have to recompute it. Theoretically though, at the very least, we could do plus floppy to V. Quality of the segment. Of course, the problem with doing this is you have to recompute it every time you update the bloody network. But theoretically, we could do something like this. And then this could fix the problem of not being able to rank experience by reward alone. What does a Q function give you for this? Delay the network? You can. But, what the heck does a Q function even give you? Sample transitions or whatever, or segments. Does still not just get stale? Yes, Bet. Like, generally, what does how precisely does a Q function let you go off policy? I'm not actually seeing it when I'm looking at it closely. Suppose you sample a batch of experience. Is it just that it's recursively computed? I keep thinking of this in terms of segments, and I forget that a lot of the time people are like Q function off policy. You're literally just looking at like state action, state or reward or whatever. If this actually makes sense to me, that this would like fix problem. Okay, so this is correct because this is Q star, which is optimal policy. How does this work when you do not have Q star? It's a very different case. The tabular case, you can actually prove that it will converge. Well, I suppose it's state action state pair, like it's triples or whatever. That's kind of a world modeling objective in some sense, isn't it? But it's kind of hidden in here, no? Because you take the difference of these Q functions, you literally just get a value estimate out of it. Versus the idea, I suppose. The thing that stays fixed and is policy independent, right? The idea is that if you're in a state and you take an action in that state, then at least with the same probability, you will see the next state, right? Like that transition stays the same. Yes, it's off policy. But the key actual idea is that the the transitions don't change. That's the thing that you're exploiting. It is not dependent on the policy. Of course, it's hard to frickin' see that in all this math that's like wrapped up with other stuff. But I don't think there's anything else magic here. I think that's the key idea of it. Let me just see if there's any other framing of it in here. One. Okay, so this is a pure iterative form in a tabular case, right? Step size, reward at next time step, discount factor, the Q value, the maximum, the take the action such, if you take the action such that the Q value is maximized, what is that value? What this piece is. And this is at the next state minus the previous state. So wait. Q at this state, take this action, gets you to state t plus 1. Maximum action. Oh, wait, here. Q directly approximates Q star, which is the optimal action value function independent of the policy being followed. Directly approximate Q star, which is the optimal option. Is true in the neural net case. Determines which state action pair didn't update. All pairs continue to update. Method guarantee no. Well, clearly you can break it in the neural net case, right? Because here you're only ever updating. You're maintaining an estimate for each state in action, right? Each transition. So, like, at the very least, you can have a continual learning fail in the function approximation case, right? If you don't sample evenly in your data. One policy, though, this is not a neural net bed. It's literally a table. It's a tabular learning case. This is the original pre-DQN algorithm. This is standard Q learning. Essentially what I'm trying to do for the folks who just joined, right, is I'm trying to figure out how strong of a guarantee off-policy algorithms actually give you that you can continue to reuse whatever data you want without breaking it. I suppose in some sense, though, it is a recursive. Like, whenever you go to update your Q function, you're not going to have a stale value because, like, you're calling your value function again, so you're getting fresh value data. The problem is also it's based on a one-step bootstrap at the same time, right? So doesn't this break as soon as you try to do more than one step? Because I think that this makes sense in this, like, one-step case, right? Nothing is ever stale because you're evaluating your Q function on, this is state action reward state action. It's SARSA, right? You have SARSA data. Like, you have state action reward state action data. So nothing can ever get stale here. Now the problem is that, like, as soon as you want to do a multi-step bootstrap, right, then you are actually off of your function. I'm pretty damn sure, at least. Now, I was looking at this on the plane. There There is something that handles this later on. Let me find it. Yeah, so here, 154. End step off policy. Let's start with this. End step off policy. Okay, so there is an important sampling thing that you can do here. Is this actually fully correct for it, though? I suppose it does, doesn't it? Wait. Hang on. No, there's a gotcha here. Hold on. High is the stale one. Yeah, this can blow up. Can it not? Yeah, this can totally blow up. Hmm. Yeah, so the thing is, right, yes, okay, so here's the issue. You can still technically get some information out of an old sequence that's with a very different policy. But like it's not actually suppose the only case in which it's actually useful is if it's like expert data, right? Makes sense if it's expert data. It does. So yeah, I mean, in that case then, right? Data that's collected with a clumsy policy, like a segment that's collected from a clumsy policy is simply not going to be useful for anything other than a world modeling objective. But if you have a good segment, let's say you get lucky even, then you can still kind of use it. If you have expert data, I think this important sampling ratio actually helps you a lot. Yes. Solved env policy. Yeah, I did that before today, Bet. It's something slightly different. It mostly works if you do that, even if you do like the most naive possible way. It's not perfect, surprisingly. Like the behavioral cloning objective is surprisingly not just perfect, but it does train something in pretty much all cases. I mean, regardless though, right? Like I don't think the same convergence guarantees hold. Because it's a neural net, right? So if you think of a neural net like a water balloon or like a whatever, like you push it in one area and it's gonna blub out in another area. So like the reason that if you train it on like bad historical data, it's gonna be bad. Should it be strictly better to train on more data than less data? Let's say the data set is sufficiently large. I think the answer in theory is yes, but in practice there are a lot of other factors. There's no label. The rewards are always correct. It's ground truth data. RL's ground truth data always. I'm asking in the RL case specifically. You assume the rewards are always perfectly correct. It's more important in this case though, right? It's like the RL case is different here. So I suppose if you take the supervised case, then the answer is no. So the answer here, probably also no for sufficiently degenerate data, which you could very easily end up getting. Okay. We have this end step off policy. Cool. And let's see what this is. Is this actually a clean algorithm? Hang on. Clean as in it's not Rainbow. Like, Rainbow has a bunch of crap bolted onto it. Why is this worse than... Hang on, that's sketchy as hell, isn't it? Wait, why? Okay, so this actually doesn't work. Yeah, this does not work. This is continuous control specific. That's a good thing that I found that. Doesn't remotely work out of the box. Okay. I'm gonna have to read a bunch of this math at some point. This definitely is not an out of the box. It's a good thing that I found that ablation. Ablations on this. It is. You get rid of dueling, doesn't do anything. Does a little bit some. Get rid of double. Double is funny that you up. A lot of these hurt. It's actually funny, the distributional one gets the closest. You just took a couple of these tricks. Prioritize replay plus probably gets most of it. Move duel. Only 4 tricks. Cut out these dumb ones. How many of these do I have in our current thing? We have priority, we have multi-step. What's noisy? Distribution is what Spencer was doing. What is noisy? Stochastic network layers for exploration. That's horrifying. Okay, but we kind of have most of these now, don't we? How do you do, what's the continuous sample look like for a Q function? Is it bucketed? I'd like to try kill Gauss in the. It's funny though that you get rid of DDQN and it still works. It's actually cleaner, isn't it? Work lock. Okay, well, I think it makes sense for me to start messing around with off-pol tomorrow. Um, Definitely something being able to keep data around. Likewise, I haven't been able to get any form of um, pure imitation, like best of n data, be remotely as close on policy as like on policy RL. So the question then should be, if I replace the on policy formulation with an off policy formulation, something way closer that should be theoretically even almost directly comparable, what happens? Like, kind of haven't done that. Spencer's done HL Gauss for the value function. specifically, but that's kind of a different thing. Oh, you don't need HL Gauss on. Hang on. What is the distributional? Let me look up this last thing. I see. Oh, I think I get it. Yeah. Because you get a quadratic loss with standard DQN, right? You'd actually want something like HL Gauss. I see. Yeah, this one. Do HL Gauss for this. Best, okay. Message Spencer on this real quick. Eh, funny. I mentioned this before, this action thing. Alright. That's pretty much a good view. Let me find Spencer. Okay, so we have a few extra hours. I think what we can do is we can start on the other new project. There are two projects that I came away from RLC with, right? One is actually figuring out the sample efficiency thing. So you see, I've been doing imitation. When a try-off policy, there are lots of things to mess around with there, right? Um, the other thing is getting an actually clean test suite of environments for really determining which of this works and doesn't. So there's this paper, which is a well motivated, but with a clumsy execution in my mind. So what they try to do is they try to come up with environments that measure agent capabilities, like Pokemon, on this well, what will forever be in my mind the Pokemon chart, because that's where I first saw it. Um, but these different axes Like, I don't think these are actually the axes that you want. Make a doc for this. Oh, perfect. Spencer's running sweeps. For puffer bench, let's think of some things here. Um, let's just type some keywords in. So they talk about like generalization, exploration, memory, noise, credit assignment. I don't think this is a good basis because in my mind, right, what's this? So this is robustness, noise, right? Scale. Just take these out immediately. Credit assignment require memory. It does, doesn't it? Well, it doesn't require the agent to have memory. It requires the algorithm to have like a multi-step thing to it. But in our case, right, actual intelligence, credit assignment requires memory, fundamentally. Requires memory. Credit assignment as a problem is actually not a component vector, is it? Like, credit assignment is a higher level topic in some sense, right? Or is it fundamental? How would you set up an RL problem that does not require credit assignment? Are you limited to like one-step problems? Credit assignment is like a blanket term, no? And let me answer one message about this. These are bad. Okay, let me sort of explain what I'm thinking here. The problem is that these are bad basis vectors, right? This was like if I were, instead of giving you, if I'm trying to cover a space, and in this case, the space we're trying to cover is like difficulty in RL, and instead of giving you like X, Y, Z, I give you like 2X plus Z, and like X minus Y plus 3Z, and then like 3Z minus Y or something. That's even independent. Like, yeah, probably is, has to be. But yeah, it's just like a really crappy basis. So we're trying to think like what are the actual like in order for something to be a basis vector, we have to be able to test it on its own cleanly somehow. I suppose one of the things that messes with this, right, is there's a difference between the algorithm being able to do credit assignment and the agent being able to do credit assignment, right? Because they have RNN, boot DQN. Where is this? Where's this again? Charts. Credit assignment. Okay, so this is tiny, but this is DQN having positive score in all the credit assignment tasks. So basically, what they have this umbrella length task where it's like you you have to make a decision and then you only get the reward a long time after that. So an algorithm can do credit assignment even if the agent has no idea. The agent is taught to make the right decision based on the context, but it itself cannot do credit assignment, which means it can't do in context learning or anything either. Maybe am I looking at this the correct way? Instead, think about hard problems that we solve and what makes them hard. Discounting horizon. What if we wanted to build, like, what are the actual hard problems we care about? I kind of want to just like, can I instead think of like very simple games that test stuff that's not in PufferLib? What if we do like a recipe game? All right. Each reset has several rounds. Round presents some ingredients. Round and target item. Um, stay the same. That does. What's this thing test? This thing tests in context learning for sure. Is that any different though? Or you could have all the ingredients. Yeah, you could have all the ingredients, right? Okay, I think that this one is decent. This is like a cool little nifty game. Can I come up with a few others like this? This is like this in context learning type thing. kind of meta learny and context learny, whatever. Is there something I can do to test like really long games? Because progressive games have like there's several challenges to them, right? Do I want to test pure memory though? PufferLib be applied. Basically anything that you go to make it better. We focus on fast environments, so like all our defaults are optimized around environments being fast. Obviously, we have ways to make a lot of environments fast, but yeah, it can be applied to a lot of stuff. Like our implementation is just generally better. It's not exactly PPO; it's a better algorithm. Okay, I like this recipe game. Generalization, exploration, memory, credit. Okay, there's control as a problem. G Suite test scenarios, pretty much. Binding peptide generation. I don't know what the simulator used is for that. If that's a simulator in a loop, then I mean like molecular simulation is probably the thing I'm most interested in overall in RL. It's just hard. Really is the most interesting thing out there. What is something like Sokoban? It's hard to actually come up with very good tests for agents, right? Takes a lot of thought. Oh, literally that concept merger game does this, doesn't it? Environment select. There's not going to be a mathematical categorization like that. Like, you could do that, but that's not actually the important one. Okay, an alternative version of this would be like, I don't know if this one has enough structure. Yeah, I don't know if that one has enough structure. The recipe game sounds better to me. Are these not the same game? Oh yeah, these literally are the same game, aren't they? Yeah, these literally are two different just flavors of the same game. That's exploration in some sense, isn't it? That's exploration, that's in context learning. That actually tests a lot of good stuff. A bunch of related ideas. There's precise control. Precise control even really a thing? Load down to you. There's also the really long horizon stuff. How do we do that? Like, a lot of these tasks are kind of hard just because they change a little bit over time. Horizons are really long. And you introduce new types of stuff over long horizons. That's true of neural MMO. What are some other environments that I liked that I've done before, right? So I've done stuff like passcodes, like guess a passcode. It's like memory related. That's an exploration problem as well, in some sense. How is this different from the recipe game? Recipe game has an additional element to it. Password guessing game is pure exploration is interesting. Not pure exploration, it's also memory. There is really no credit assignment, though, which is kind of interesting. The two things missing. What other things are missing? Really, like the length and progression of a game. Hang on, no, you can get both of these in this. You can actually get both of these. I always say Tetris looks nice. It does. Tetris looks very nice. Length and progression we can get just by making these very long, right? The recipe game in particular. Okay, let's say that we have a game. Let's say that we have a game in which we have like a bunch of ingredients, right? Let's say it's like a decent number of them, like this. Like, suppose we extend this, right? Let's say that we start off with 5 ingredients, okay? And we need to make a 2-slot recipe. To pick 2 of these, fill the slots, then you get out a result. And the recipes don't change, so they're already set, you just don't know what they are. Alright? And then, we do some of these, you end up getting... Always do 2-slot recipes, more than 2-slot recipes. And it could be that you end up being able to use products that you've made before. So the initial set of recipes can use anything in here, and then whenever you make a product, it can also use that. And the game can progress. At a certain point, you unlock new ingredients to use. Now there are a whole bunch of new recipes that can also use these. Keep going with this. What qualities does this game have? Well, obviously it requires memory. It requires exploration. The combination of both of these over several rounds is what you would call in-context learning, right? So it does require in-context learning. There is a concrete strategy from game to game that you can learn. It has the potential to scale to very long horizons. It's a progressive game where you actually have to play it for a while to see all the content, which is one of the key things that's difficult because like you have to play through the early game to get to the end game. You get dramatically less experience at the end game unless you get good at getting there quickly. It doesn't have any control aspect. Main thing missing is like some sort of control aspect. Now, I suppose the thing that this doesn't do, right? This gives you like a good total task. The thing that this doesn't do is separate them into individual tests. So, like, it's possible we end up with a really good environment for research. Nice thing about it is you only have to run one hyperparameter. Well, but disentangling these is very different. Memory is pretty easy to test on internet. Or no, because it's still credit assignment. How do you test memory without credit assignment in RL, right? Coming up with a good joint test is actually there a reason that you want to separate these? You can't come up with a memory independent of credit assignment task. They're basically completely commingled. Okay. What about exploration? What does exploration mean? Again, I don't think it has meaning on its own. It has to mean learning an exploration strategy more so than the algorithm having one, right? The recipe game counts as that. We could come up with a purer test. Oh, memory. Could do Asian grid full passive maze. What variation is that bet? Oh, so that would mean like the algorithm itself. That would be exploration encoded at the algorithm level. The RL one though, that's for memory independent. Let me think. I guess there's like a question of what it means for what it means for an algorithm to be good at exploration versus okay. Oh wait, yeah, you can do this, right? Because oh yeah, you just do like the umbrella problem, right? Yeah, it's like okay, you just do the memory problem, but you can observe your choice, right? Wait, actually, what did they do for pure memory? Memory cards. Long T maze. Oh, is it because for the final action you immediately get? I see, you just flip it. So it's like you get presented the thing at the start. You have to remember it the full way, but you get rewarded instantly. And then credit assignment, your action doesn't matter at the end. Okay. So we can actually do this. Yeah, we can actually do this. So for memory, all you need to do is um first final action sides word take credit first action. Okay, so you can actually perfectly isolate memory and credit assignment. Okay, that's fine. I don't know if there are any of these others that you can actually isolate so cleanly. Hmm. Honestly, you can very easily come up with a task that requires exploration, and like exploration has to be learned. The password game requires exploration. The recipe game requires exploration. Password game also requires memory. Well, I suppose it depends, right? You could make a version of it that doesn't. I guess there are like a few different versions of this people talk about. Like, what about like just the big empty room thing? Yeah, it's difficult to come up with a good version of that, right? What's like an actual reasonable exploration task? I guess there's there's the learn and exploration strategy, and there's the does your learning algorithm have an exploration strategy in it, regardless of reward, I guess. Tough to think what to what extent I care about these, I guess. Varsity. I could frame a lot of these as lock games, couldn't I? Think about this. I'm trying to think if I can like phrase these all as like passcode guessing games somehow. This would actually be cool because I could potentially test them all at the same time, right? Generalization is generalized. I'm trying to think what the way that you structure something like, right? Just have the bar. You can observe. Just have a sequence that you can observe. First action decides, yeah, given many. Let me see how this would work, right? So if we have something like this, have like tape, like your clue, your final action decides reward, which one is given on the first. Like shade this. This is essentially your take this action. This is shown on the first. You get any results from IL? We got some crazy results, but not enough to like go sub it in just right away. So we have it working like surprisingly well on some hard environments. It does really well on the first chunk of Neural MMO3. It insta solves Cartpole and Pong, but then like it does very poorly. It does better than random on most stuff, but like it does very poorly on Breakout and Triple Triad and a bunch of other tasks. So I think that we definitely have learned from this that we need to be able to reuse samples, especially the high value ones, and that the IL objective is pretty good. But it's going to take some time to figure out how to integrate that nicely. I'm taking a little break at the moment, and I'm working on some benchmark environments. Okay, so the clue can change on each time step. Clue can change on each time step. Passcode is random. Password doesn't change. That in context learning. How is in context learning different from memory? Well, an application of memory, right? You push the code somewhere so I can check that out. The slightly old version is on, I believe, the imitate branch. And I will push this stuff today as well. Just maintain my train of thought a little bit here. This segment of the stream is probably fairly boring, but it's very important because I'm trying to think about simple test environments for specific things. I'd like to have some more of these. Basically, a Puffer Ocean Sanity V2. It's in PufferLib. It's just a branch. Imitate branch. I'll push all the new stuff. I added in like an expert model so that you can like load in an expert if you want and like test imitation on that to see if that mostly works. Do here. Mel. Yeah, funny. Puffer just solved everything. I don't know. You. Yeah, that's kind of obnoxious to do, bet. Well, one, it's pedantic, and two, I guarantee you a bunch of people aren't going to want to like have to prepare an oral defense of their code on like live on the stream. That is mostly how an oral defense works. Help me figure out how to do these environments instead. Cool. Um, there are several tricky things here, right? Not quite exploration if the same bloody sequence of actions is always correct. Well, it's not quite. The memory and credit assignment ones are solid. I think the sparsity one is good. Why Rust and C devs are fighting on X? They have nothing better to do. You can go grab some of the C devs and they can come work on this if they know what they're doing. The pros of Rust are that you feel smart. Cons are that you're not. The pros of C are that you are smart. The cons are you don't feel smart. Take your pick. Totally not bait. Exploration task. Go. Yeah, I'm trying to think if there's a better way of doing any of this stuff. See, this is still not memory. Actually, your final action decides reward. Which one to take is given on the first step. You still have to do credit assignment, don't you? Or association. You still have to do association. Am I wrong, Bet? The credit assignment one works. Your first action decides reward, which is then given many steps later. The credit assignment task is correct. The memory task seems wrong to me. Why the no op? What do you mean? So the memory game is supposed to be, I tell you what action to take on the last step, and I tell you it on the first step, and nothing else matters. The problem, though, is that you still have to understand the instruction. So, like, if you don't understand the instruction, that's not a pure test of memory, so it doesn't work, tabula rasa. Yeah, we're using RL. Do minimal tasks, I think, are more useful for diagnosing like specific architecture deficiencies. Like, I have a memory one that's linked to credit assignment that's kind of decent because it's like a fundamental check. I don't know if the other ones are even good. I kind of like this recipe game. Preset has several rounds. You can increase sparsity by just changing the number of ingredients. The only other thing we haven't done is like control, I guess, right? You don't want to introduce a control problem to this. Doesn't this do everything but control? Actually, let's see. Is there anything that is in any of these M's that is not control that is not covered by this? So what does neural MMO require you to do? You have to explore. There's sparsity. You have to learn to fight agents. They're like associations that go over time, I suppose. The associations over time part. Actually, is this it? They tell you the recipe. Yeah, it's different though. Oh, I suppose, yeah, it doesn't have any of the multi-agent in it yet, right? So this is not... Hmm. Neural MMO has... Some of these actions are poorly extended. But I suppose the recipes get longer. Never get that long, though, do they? It's kind of interesting that, like, making a pure task for this is hard. Well, of course it's hard, right? We wouldn't need all these tasks otherwise. It's completely missing control. Like, honestly, outside of these little probe environments, I'm actually reconsidering the idea. Like, isn't literally just having these different little RL environments better? These different game environments? I still think the recipe environment is on its own pretty reasonable. Like in context learning as well. Good. Okay, well, I like the recipe game. I like the idea of sprucing up some of the individual ocean, like sparse, like test environments. I have a decent number of ideas here, enough that I could start implementing stuff. It's 5:30 still. Let me go check a couple quick things off to the side. Okay. Um, want to start on these. So I want to try Gauss. Also, do I want to have separate C environments for sanities? Kind of tired for today. I've thought a lot about a lot of different things and done a lot of thinking about all this stuff. Um, a quick look at what we have in Ocean right now. I'll also commit this, right? All right. Bandit memory, multi-agent password spaces for all the environments. Could modernize these up for sure. Game. Yeah, there is an alchemy benchmark. Oh wait, there is. This is a thing. Well, I mean, this is a good idea implemented in the stupidest possible way. Local DeepMind. Do this in frickin' Unity. You gotta be kidding me. Yep. Cool. Alright, well, there's literally a basis for this thing. How many citations does this paper have? 43? That's so funny. Wait, NERP's 2025? This is 2021. Did they then submit this? Oh no, this is 2021. Okay. It has the date wrong. Why is it in the proceedings 2025? No, it says papers 2021. Okay, it's just mislabeled. It's not V2, it's just mislabeled. Well, of course, nobody ever used it, right? Like, literally nobody used it because they implemented it in the dumbest possible way. Like, imagine having a good idea and then implementing it as a fucking Unity environment. Like, are you insane? So I can still take the name Alchemy for this. I find it very funny though that like I come up with the name Alchemy for this. I Google Alchemy RL just to see, and then somebody has a very, very similar idea under the same name already, just not executed well. It's more just they don't have good I think they have engineers and they have scientists, but like they don't actually think about what the other person needs at all. Annexating the current. Yeah. It's just kind of stupid if you think about it, right? And Next time I'm trying to do is something stupid. Also, Genie, except for Puffer, I'm making action space the output. What? Action space the output for. Yeah, if you're gonna use RL to learn a world model, that's a terrible idea. Um, what you would do is you would do that at the algorithm level. If you want to do a world modeling objective, you do that at the algorithm level, and you can do it on pixels or not pixels. World models are not constrained to just pixels. They can work on different obs types. Ideally, though, a lot like sometimes you do world model objectives not in pixel space or in ob space. You do it in embedding space so that you don't have to deal with the reconstruction as much. Very probably. Well, I mean, it depends. Like, if you come up with some sort of world model thing that's actually generally useful on the algorithm side, then yes. But that's hard to do. That's a very high bar. And just think of like some basic stuff I'm gonna want in here. So you have um want recipe. What do we want? Okay, I want to do this. Make the recipes a big array. No, we can't make the recipes a big array because we have to check them, right? Check them. Make a big ND array, don't you? Yeah, you'd make the recipes would be a big ND array. Want to restrict it to 2 ingredients? Really? Well, we would just do like we're not gonna have a huge number of different ones, right? Just do 2D. Probably interesting enough, right? Okay. This. We have to generate all the recipes, right? We're gonna have to come up with a generation algorithm, I'm sure. This. Oh. What's the... Maybe we just do this top to bottom. Like, let's start on the generation algorithm. Okay, so know what level we're in. Know how many products there. Do products per level or something as well. But like, so it's gonna be something to the effect of Alright, so you just pick 2 ingredients. The product, we have to think through the dynamics quite a bit of this. Hello, how's it going? Hey Spencer, yeah, it's a dedicated test environment for some things that's kind of complicated, but I don't know, not that bad. There's actually kind of precedent for it as well. There's an old DeepMind paper that's kind of similar. I came up with the idea, then I Googled to see if anybody had done it, and there's like something similar, but of course it's like that one's like 100,000 times slower than it should be. I got some pretty cool results though throughout the day, and I'm about to end stream because it's 6, so I'm gonna go get dinner. Um, but yeah, Spencer, I got a lot of interesting results. Cracked out HL Gauss for more 8. Um, maybe we try both. Did it push VF? If it pushed clipping to like really low, then I don't want that one. Clipping really low usually means like cracked out unstable, like completely unreproducible. I want to do like off policy learning stuff tomorrow. What about the clipping? Oh yeah, you're right. That might be a problem. Like not clipping the loss somehow. Hmm. Yeah. Well, try the slightly more conservative one. We can try both to be fair. I just want to run it on the 5090. Min max value bins. Yeah, a different type of clipping though. That's prediction space clipping. I mean loss space clipping. have that up here. One cool. Yeah, I'm gonna want to try to play with that tomorrow. I'm pretty tired at the moment. So stuff I did today for record, Spencer. So pure imitation learning with no reinforcement learning can get like 67% on tower climb. Like the same number of steps and everything. It also solves the first chunk of neural MMO faster than our current RL, and it solves cart pull instantly and pulling instantly. It fails hard on a lot of other ends, even simple ones, though. So I don't think necessarily this is going to be like, oh yeah, we immediately just use this. But I think this is pretty strong evidence that if we get an off-policy thing or like an auxiliary thing working, that we can definitely use past data in a way that's very effective. It's pretty nutty. I also found some good references. I have one question to email to send via email to someone, but yeah. Suffice to say, I mean, research progress is always slow in the sense that like no, nothing just like works out of the box on everything yet, but we got some cool information from today. It is very tiring. I also did a lot of work looking through sanity tasks and like B suite stuff and like how we can isolate different tasks. And I got some ideas for that, as well as one idea for this like combined environment that would be a very good benchmark for I think it'll just end up being a very good benchmark overall more than anything. Mm, Spencer, I don't know. It's probably just learning. I don't know if he has done action masking or stuff. It could just be learning invalid actions. I just say. This thing gets to be quadratic is the problem. All right, well, I gotta go for dinner, guys. I'm on a pretty funny schedule these days. Be back in the morning for tuning into the research stream. Tomorrow we will be doing off policy, possibly looking at the environment if I get bored of that. But yeah, lots of work to be done. So if you're interested in my stuff generally, everything I do is at puffer.ai. Somebody please fix these graphics. These should be cars. But yeah, all my stuff's at puffer.ai. Start the repo. It's free. Helps me out. If you want to get involved with research, join the Discord. If you want to build environments, join the Discord. And other than that, all my stuff is at X here. Articles. We have all sorts of stuff there.